In our search for alien life, we can receive only one of two answers. Either we are someday able to find and communicate with another civilization, or we unearth only more and more silence. We receive a signal, or we don't. Either way, we come to an important realization about our place in the universe. Not many of us want to believe, and not many of us do believe, that we are alone. Currently, we have identified over 5,000 exoplanets, but with cutting-edge observatories like the James Webb Space Telescope and ambitious projects like Starshade on the horizon, this number is expected to increase significantly. These advanced tools will enable us to better analyze exoplanets and assess their potential habitability. The presence of certain characteristics, such as seasonal changes, liquid water on the surface, or specific organic compounds, might point to the possibility of life. However, even if we find a planet with promising conditions, that alone does not guarantee the presence of life. Life might never have emerged on that world, or if it did, it could have been wiped out by catastrophic events like massive impacts or nearby supernova explosions. Planets that show signs of potential habitability and harbor the necessary conditions for life to emerge becomes one of the prime suspects for study. Specific organic compounds like chlorophyll, which are predominantly produced by living organisms, could be key indicators. Additionally, signatures of large biomass, such as those found in rainforests, could create discernible changes in environmental parameters like temperature or cloud distribution, setting them apart from barren landscapes of rocks and sand. In our search for life, we must remain open to the possibility of encountering various forms of intelligence and evolution. It's essential to remember that life's timeline on Earth spans billions of years, from microbial life existing for roughly 4 billion years to recent technologically advanced life emerging only in the last 100 years. Considering the vastness of the universe and the diverse array of conditions on other planets, it is plausible that we may discover life forms at different stages of evolution. Some might be in their early stages of development, akin to the ancient microbial life that once dominated Earth, while others could be on a path toward advanced civilizations, much like our own relatively recent technological achievements. But you see, as humans, our understanding of intelligence, civilization, and communication is deeply rooted in our own experiences and societal norms. However, projecting our behaviors onto potential alien life forms might lead us astray in our quest to decipher the paradox. Imagine civilizations that have evolved on distant planets, under entirely different conditions and evolutionary pathways. These alien societies might possess cognitive abilities, values, and methods of communication far beyond our current comprehension. Their understanding of the universe, science, and technology could be vastly different from ours, making their approach to space exploration and communication unconventional by our standards. While we search for extraterrestrial intelligence through radio signals and other technological means, advanced alien beings might have developed alternative forms of communication that we have not yet fathomed. Their methods could transcend our comprehension, existing on planes beyond our current grasp of physics and biology. Moreover, the very concept of intelligence might vary significantly among different species. Intelligence on Earth can manifest in various ways, from human cognitive abilities to the sophisticated social structures of certain animal species. Similarly, alien intelligence could encompass an astonishing array of forms, making it challenging for us to recognize and understand. Furthermore, the Fermi Paradox relies on the assumption that advanced alien civilizations would exhibit expansionist tendencies, similar to our historical exploration and colonization drives. However, this assumption could be overly anthropocentric, as the motives driving an extraterrestrial civilization might be entirely different from our own. Consider the possibility that some advanced alien civilizations prioritize harmony with their environments and seek to preserve their own planets rather than colonizing others. Perhaps they have found a sustainable balance and prefer to remain hidden from other civilizations, avoiding potential conflicts that could arise from interstellar contact. In essence, this solution to the Fermi Paradox encourages us to broaden our horizons and remain humble in the face of the unknown. We must embrace the diversity of potential alien behaviors, acknowledging that our understanding of intelligence and societal behavior might be just one of countless possibilities in the vast cosmic landscape. Studying the patterns of human civilizations, scientists observed that many rose to greatness but eventually faced collapse. Similarly, when investigating the history of large cities, they noticed that most reached a certain point of growth and development, only to experience a subsequent decline. These findings served as the foundation for a hypothesis regarding the fate of any alien space civilizations. The hypothesis proposed two possible scenarios for these extraterrestrial civilizations. In the first scenario, a civilization would reach a critical point where it became aware of its exponential growth and recognized the dangers of expanding too far and too fast. In response, they would choose to halt their interstellar travels and refrain from further colonizing other worlds. In the second scenario, a civilization might fail to recognize the impending consequences of their expansion and continue their encroachment until a point of no return, leading to their eventual collapse. Remarkably, from our perspective, both scenarios would yield the same result: aliens not visiting us or revealing evidence of their existence. The distance between their civilization and ours would simply be too vast for meaningful contact or detection. The researchers dubbed this hypothesis superlinear scaling. According to this concept, a civilization grows exponentially, spreading out and colonizing other worlds, fueled by its increasing energy demands. However, as they venture further and expand, they may encounter challenges in sustaining the immense energy requirements of such vast colonization efforts. Unless they take timely action to address these issues, they would eventually reach a point of no return, a singularity, where the collapse of their civilization becomes unavoidable. Interestingly, the researchers highlighted that if these alien civilizations were closer to us, we would likely detect signs of their existence, especially if they were on the brink of collapse. At this stage, they would be emitting enormous amounts of energy, making their presence conspicuous. This hypothesis is particularly intriguing when considering other assumptions proposed in the search for alien life. The first assumption posits that advanced civilizations may not prioritize exploring planets teeming with life, especially those in the early stages of development. It is possible that these civilizations have encountered numerous biotic worlds throughout the galaxy, but the allocation of resources to investigate each one may not be practical. Moreover, attempting to communicate with primitive life forms might not yield meaningful outcomes, rendering such efforts less appealing to advanced beings. On the other hand, the second assumption highlights that once a planet develops intelligent life, it becomes far more intriguing to advanced civilizations. The rarity of intelligent life in the galaxy makes each instance of it noteworthy. Detecting signs of intelligence from afar, similar to our SETI project, becomes a priority for these civilizations. Considering the Earth's perspective, the most detectable signs of our intelligence would be the radio signals transmitted over the past century. These signals could have potentially reached around 1,300 star systems within a radius of 50 light-years out of the 100 billion to 400 billion star systems in the Milky Way. However, the radio signals, unintentional techno-signatures, would become indistinguishable from background noise after traveling for about a light-year. With this in mind, the proposed solution suggests that even in the 1,300 star systems that could have received our signals, there is a significant chance that they wouldn't have been able to detect our unintentional transmissions. Moreover, if non-intelligent life is abundant in the galaxy, advanced civilizations might not see a reason to expend resources trying to contact potentially non-intelligent worlds. Therefore, the silence from extraterrestrial civilizations could be attributed to their lack of evidence of intelligent life on Earth. The vastness of the galaxy and the challenges of detecting intelligent civilizations from afar make it plausible that advanced alien beings have not yet noticed any indication of our intelligence. Rare Earth, proposed by Peter Ward and Ron Brownlee, suggests that the unique combination of geological and environmental conditions on Earth makes the evolution of complex and intelligent life exceedingly rare in the universe. They argue that while microbial life might emerge on some planets, the development of sophisticated life forms is highly unlikely. However, a counter-hypothesis called cosmic zoo, proposed by William Baines and his colleague, takes a different stance. They believe that just as there are various styles of music, there are multiple ways for life to evolve from simple microbes to complex macroscopic creatures similar to animals and plants. The cosmic zoo hypothesis suggests that once life arises on a planet, it has the potential to evolve into diverse and substantial forms, provided the planet remains habitable long enough. While the debate continues, two critical caveats exist. Firstly, the origin of life on Earth, despite not being considered a unique event, remains shrouded in mystery, leaving room for the possibility that Earth's conditions are indeed rare. Secondly, the evolution of technologically advanced life, exemplified by humans on Earth, seems to have occurred just once. This uniqueness makes it challenging to estimate how common such advanced civilizations might be on other worlds. To determine which hypothesis holds true, scientists turn their attention to our own solar system. Several planets and moons, including Mars, Europa, Enceladus, Titan, and Venus, present opportunities to search for microbial life. The discovery of independently originated microbes in these locations would suggest that life is widespread in the cosmos, providing a significant data point. However, to differentiate between rare Earth and cosmic zoo, the quest for complex macroscopic life demands exploration beyond our solar system. Europa, with its subsurface ocean beneath an icy crust, offers a tantalizing possibility for such life, as hydrothermal vents on its ocean floor could potentially support animal life. Nevertheless, the search for intelligent life necessitates looking further afield, to exoplanets orbiting stars beyond our sun. In 1961, Frank Drake, an American astronomer, created a simple equation to estimate the number of intelligent civilizations in our galaxy. Using rough approximations, Drake calculated that there were at least 1,000 and perhaps as many as 100 million extraterrestrial civilizations in the Milky Way alone, but these numbers are highly disputed. Perhaps life needs a planetary solar system with gas giants far from the sun and rocky planets closer in. Maybe plate tectonics and volcanoes are necessary to create a suitable atmosphere for life. Evolving life may need a large moon that causes tides, a specific temperature, or a planet with a stable orbit. With a sample size of 1, the only thing we know for sure is that life developed on Earth. It's nearly impossible to determine whether or not life is rare in the universe. In a paper called Eternal Inflation and Its Implications, Alan Guth, a theoretical physicist, used the physics of inflation to elegantly show that each universe, and by the way, we're assuming the existence of an infinite number of universes, likely has only one advanced civilization. Here's how the argument goes. According to Guth, cosmic inflation spawns an infinite number of pocket universes at an extraordinary rate. In fact, every second, the number of pocket universes increases by a factor of 10 to power 37. Therefore, Guth argues, we can assume that young pocket universes vastly outnumber older universes. In other words, the average universe is remarkably young. Guth then postulates that there is a minimum time, let's call it T, required for intelligent life like ours to develop. Because we've already developed, we know that the age of our universe is greater than or equal to T. Let's imagine there is another civilization in our universe more advanced than ours, and for the sake of argument, let's assume that it is 1 second more advanced. If the minimum time for our civilization to develop is T, the minimum time for this more advanced civilization to develop is greater than or equal to T plus 1 second. Because the number of universes that satisfy the T requirement is 10 to the power of 37 times the number of universes that satisfy the T plus 1 second requirement, and because we know only that we live in a universe that satisfies the T requirement, it is extremely unlikely that our universe also satisfies the T plus 1 second requirement. It's unlikely, therefore, that there is an alien civilization in our own universe even 1 second more advanced than ours. Everything I just said might be a little bit confusing. Let me take another approach. Imagine the universe as a vast and diverse canvas where countless paintings of reality come to life. Each painting represents a unique world with its own story and inhabitants. Now, in this cosmic art gallery, new paintings are continuously being added to the gallery, appearing like magic with each passing moment. However, most of these new paintings are still fresh and not fully developed. Guth believes that for intelligent life to emerge and flourish within a painting, it requires a certain amount of time, like a masterpiece slowly taking shape. So, in some paintings, life might just be taking its first strokes, while in others it may have had more time to evolve and grow. Now, here's where it gets intriguing. Imagine there's another painting nearby where life is slightly more advanced than in ours, just a tiny step ahead. According to Guth's theory, the number of paintings with life at our current level is immensely greater than the ones where civilizations are just a tiny bit more advanced. Because the gallery is filled with countless paintings at our level, it becomes highly unlikely that we would find one where a civilization is only a small increment ahead. So it's quite possible that our painting holds one of the most advanced civilizations in this grand cosmic artistry. Guth's idea can be illustrated in this idea of multiple paintings and unique civilizations, adding a captivating perspective to our understanding of the universe. It prompts us to ponder the diversity of life and intelligence across this cosmic gallery, leaving us in awe of the infinite possibilities that await beyond our own canvas. Nick Bostrom, a philosopher at Oxford and director of the Future of Humanity Institute, developed an argument in a paper called "Are You Living in a Computer Simulation?" He argues that at least one of the following three statements must be true. It's either humans are likely to go extinct before they are post-human and able to create entirely simulated realities. A post-human civilization with the ability to run such a simulation would likely not run many simulations. We are currently living in a computer simulation. Now, using ingenious logic and mathematical reasoning, Bostrom puts forth a thought-provoking conclusion. He argues that unless we are already residing in a simulation, the belief that we will eventually become post-humans capable of running ancestor simulations is likely false. Consider the idea of how such a simulation could be created. Speculations from writers suggest that an advanced Type 2 or 3 civilization might construct a colossal computer system known as a Matryoshka brain. This unfathomably massive system would harness the entire energy output of a star, utilizing a Dyson sphere, which is a shell surrounding the star to capture all its energy. Mathematicians have pondered the capabilities of a Matryoshka brain and calculated that it could possess enough computational power to create an entire simulated universe, where we, among countless other beings, could be living unknowingly. Remarkably, this concept doesn't seem to violate any known laws of physics. It sparks a fascinating exploration of the nature of reality, the potential existence of advanced civilizations, and the profound implications of our place in a vast simulated universe. If we entertain the notion that we are living in a simulated universe, created by a highly advanced civilization with a Matryoshka brain or a similar vast computational system, then the question of the existence of extraterrestrial life takes on a new perspective. In this simulated reality, the beings responsible for creating the simulation could have engineered various scenarios and worlds, including ones with intelligent life forms like us. These simulated beings, including potential aliens, might be part of the design of this grand cosmic experiment. Furthermore, if the creators of the simulation possess the ability to manipulate the parameters and variables of the simulated universe, they could introduce diverse life forms and civilizations, including those of extraterrestrial origin. As a result, the presence of aliens within this simulated reality becomes a plausible possibility. From our standpoint as simulated beings, the search for extraterrestrial life might lead to intriguing questions. Are other intelligent civilizations we encounter real entities living in their own separate simulations, or are they simulated entities like us? Moreover, if we are part of a simulated universe, the Fermi Paradox could be reevaluated. Perhaps the silence from alien civilizations is a deliberate design of the simulation, or the result of the limitations imposed by the creators. In the realm of quantum mechanics, entanglement allows two particles to become correlated in such a way that the state of one particle is instantly connected to the state of another, regardless of the distance between them. Superposition, on the other hand, allows quantum particles to exist in multiple states simultaneously. Imagine a scenario where advanced alien civilizations encode their communications and energy emissions using quantum-entangled particles and superposition states. By doing so, they can create encrypted signals that appear as random noise or background radiation to less advanced civilizations' detection technologies. To an outsider, it would seem as if these advanced civilizations do not emit any detectable signals or energy signatures, leading us to perceive them as silent or non-existent. In reality, they are actively communicating and functioning within the universe. but their quantum information hiding techniques make them invisible to conventional detection methods. Furthermore, these civilizations might have developed quantum cloaking technologies that render their spacecraft and installations non-transparent to electromagnetic waves. This would enable them to move through space undetected, making it challenging for us to observe their presence. Maybe we haven't found alien life yet because their technology is so advanced that it's indistinguishable from nature. Maybe alien life exists in a form that we haven't even considered yet, like beings made of energy or living in an environment completely different from our own. Maybe intelligent life is out there, but it exists in a different dimension or parallel universe that we haven't discovered yet. Maybe intelligent life is waiting for us to reach a certain level of technological advancement before making contact. Maybe the universe is teeming with life, but we just haven't looked in the right places yet. Maybe intelligent life exists, but it's so far away from us that we'll never be able to make contact. Maybe intelligent life exists, but it's not interested in making contact with us. And maybe, just maybe, we are the only life form in the universe. After hearing Enrico Fermi utter his now famous paradox at Los Alamos, the physicist Leo Szilard immediately answered, "They are among us, and they call themselves Hungarians." As good an answer as any, I suppose. And that's it for the video. Thanks for watching. And what's your own solution to the Fermi Paradox? You can comment below.